My name is Chuck Haas. I'm from Drexel University and member of the Planning Committee. And the caption for our session this morning is Models for Risk-Benefit Assessment, Risk Mitigation, and Engaging the Public. I'm not sure we could have squeezed one additional comma and topic in here, but we're going to try to cover a very broad waterfront. Our first speaker this morning is Dr. Baruch Fischhoff from Carnegie Mellon University, who's also a member of the Planning Committee, on what can risk-benefit assessment do, what it cannot do, what we have learned from the past about strategies, pitfalls, and limitations of risk-benefit assessment. And I guess, Baruch, you probably take the prize for the longest title as well.
Yeah, thank you. I have 15 minutes to read my title. Let's see. Can I advance the slides from here? Or? Oh, okay, one sec. Thank you, sir. Ready, set, go. Okay. Well, thank you all for coming. It was really a fascinating day yesterday, and I hope to illuminate the piece having to do with risk and benefit assessment. So, let's see. So overview, I'd like to talk about how to define risk and benefit, how to assess risks and their expected benefits, how to communicate the risks and their expected benefits, and find out how to organize this process in order to reduce risks and increase expected benefits. So first, by way of clarification, in the domain where there are domains like cost-benefit analysis of major flood control projects in which the costs and the benefits are in very different units. In the domain that we are here, both the costs and the benefits are in the same units. These are health problems. The benefits are avoiding health problems. The risks are creating health problems. As a result, the same methodology works for both the risks and the benefits, even though the details will be different. Now, the first question is, if you're starting a risk analysis, is how do you define risk or benefits, which are, again, of the same coin. Probably the best source for this is a 20-year-old report that for an academy committee that Harvey chaired called Understanding Risks. My summary of the report is that the terms of all analyses embody values that favor some interests, that when transparent, those assumptions can be controversial, and third, that an analytical, deliberative process is needed to create socially accepted definitions. So that is, analyses are not only subjective in the sense of requiring scientific expertise, but they're also subjective in terms of the issues that they highlight and don't. The classic example in the risk literature is, how do we define risk? So you could, in principle, define risk for somebody who dies in terms of the probability of someone exposed to a hazard dying prematurely, or the number of life years that are expected to be lost with each death. You can measure things in either way, but the choice of a metric depends on whether for you a death is a death, or you value the deaths of young people more. So when accidents, the second definition would give greater attention to accidents than would the first, because accidents are disproportionately among young people who lose many years of life when they die. There are also other bases that you could use in terms of distinguishing among risks. Are they distributed equitably? Are they assumed voluntarily? Could they be catastrophic? How well are they understood? Are they controllable? Are they dread? Are they borne by future generations? The kind of issues that Laurie Garrett brought up yesterday about how we consider risks in the developed and the developing world would be one of the bases for potentially defining risks differently. You have to do it one way or the other, and in so doing, you've made a value judgment. For more on this, I'll make a plug for our little book, Risk: A Very Short Introduction, which talks about this and other things. So the second question, once you've defined risk and benefit, how do you assess them? So the standard processes for estimating risks and expected benefits are, you define the outcomes in a socially acceptable way. That's what I was just talking about. You identify the factors believed to affect those outcomes. You assess those factors using the best available scientific and the interdependencies based on observation and expert judgment. And finally, you assess the quality of your evidence. confidence. So this is what a risk model would look like. I took one, Liz Kasman is a microbiologist in our group and led a study looking at the risks of cryptosporidium outbreaks in domestic water supplies. So each of the nodes is a factor, each of the links is a presumed interdependency dependent between them. For some of them we have data, for others we just have expert judgment. There's a related exercise a few years, or just actually when on the eve of what might have been, eve of the avian flu potential pandemic, Larry Brilliant got a group of people together, and as part of Oregon, to see how we might mobilize for it, as part of that expert, we created a risk model like the one I just showed for, and like many of the other things I'm showing here, I'll just show you show you what's out there, and then you can, if you're interested, could look further. One of the models that it has is what's the set of factors that one would need to take into consideration when looking at behavioral methods for reducing a pandemic, some barrier methods, which as some people call them. So I'd like to make 3 points about how one makes analysis useful. First of all, the analysis must suit its purpose. Analysis can be either done for purposes of design, that is to identify better options by better understanding complex systems, or it can be designed to inform decisions about the acceptability of risks given the associated expected benefits by predicting outcomes. The former requires judgments of relative risk, the latter requires judgments of absolute risk. In the history of risk, the landmark reactor safety study, also known as WASH 1400 or the Rasmussen report, was a very ambitious attempt to do the latter for nuclear power. It came out in 1974. In 1976, Harold Lewis led a committee of the American Physical Society that had a critical evaluation, and then the Nuclear Regulatory Commission asked Harold to convene another committee. Here's a passage from its summary report. So it's not to strain aging eyes, I've retyped it. So we find that WASH 1400 was a conscientious and honest effort to apply the methods of fault tree, event tree analysis to an extremely complex system in order to determine the overall probability and consequences of an accident. We have found a number of sources of both conservatism and non-conservatism in the probability calculations of WASH 1400. Among the former are an inability to quantify human adaptability during the course of an accident, while among the latter are nagging issues about completeness and inadequate treatment of common cause failure. We are unable to define whether the overall probability of a core melt given in WASH 1400 is high or low, but we are certain that the error bands are understated. We cannot say by how much. Our resulting increased understanding of the full spectrum of reactor accident sequences has implications for nuclear power plant design, siting, and planning for mitigation of consequences. There have been instances in which WASH 1400 has been misused as a vehicle to judge the acceptability of reactor risks. In other cases, it may have been used prematurely as an estimate of the absolute risk of reactor accidents without a full realization of the wide band of uncertainties involved. Such use should be discouraged. So this community faces a choice about, as required to do a risk and benefit analysis. It can either do it for design purposes, which the Lewis report feels was legitimate for nuclear power, or it could use it for decision purposes in order to estimate absolute risks and benefits, in which my prediction will be it will be as indeterminate as WASH 1400 was for those purposes. Here's a source for how to look at risk analysis as a design decision by Mary O'Brien from MIT Press for about 15 years ago. Second thing, analyses must include human behavior as sources of vulnerability and resilience, one of the conclusions of the reactor safety reports. It's not just human error, but human innovation that often rescues difficult situations. Here's from that paper that I showed earlier. Here's a subsidiary figure summarizing the psychological research on compliance, psychological and sociological health, public health research on compliance. One of the things that will determine how effective barrier methods are. Gavin will be talking about this, about human factors in greater detail. I'll just make the point, this is a very old literature, and there's no reason for it to be neglected for people to view. Here's a report from the Industrial Fatigue Research Board, almost 100 years old. It has charts on failure rates in steel mills as a function of shift length, but it also has this delicacy of here's the production rate for covering chocolate as a function of time of day, and come up with your own theories about what's going on here. And another place I recommend, here's a report of this committee I was honored to be part of from the Academy, commissioned by the head of DARPA, interested in coming up with a framework for ethical, legal, and social issues in emerging and readily available technologies in national security, which would include the dual use of the technologies that we're talking about here. It came out a couple of months ago. Third, the analysis must recognize its limits. These are the standard considerations that a policymaker would need to know in order to make responsible judgments about the risks and benefits of a technology, and these will all be familiar to you. And the representation of uncertainty, well established in the literature, that if you tell people the risks are small, different people will interpret it in different ways. If you say that an chance of an accident is rare, people will interpret it in different ways. You're much better off. People like to give verbal assessments. People prefer to get quantitative assessments. There's a lovely special issue of the Philosophical Transactions of the Royal Society dedicated to this topic from a workshop a symposium about 3 years ago. This is from a paper by Phil Campbell, who some of you will know, on standard representations of uncertainty. Here's a 20-year-old figure by Granger Morgan and David Keith that has been important in illuminating the basis of disagreements regarding climate change. Here's a figure from the same Royal Society transactions from the Bank of England, which makes explicit uncertainty. An interesting part of this one, in addition to being over that sickening period when things were falling apart, is that they recognize uncertainty about the past as well as about the future. That is, if we don't know what was happening, it limits our ability to predict what will happen. So third point is about topic is communicating risks and benefit, and then Monica will be talking about this in just a minute. So I'll kind of show where it fits into the overall picture. Basic point I would make is that communication requires behavioral research. That is, there's no excuse for not doing research, for not communicating in ways that are informed by the research that is out there, and there's no excuse for not testing messages when lives, political careers, and money depend on doing it right. Why do we need to do the research? It's because our intuitions are often faulty about how well we understand other people and how well they understand us. A good portion of social psychology, if you've taken Social Psych 101, is devoted to corollaries on that basic theme, and we've got a bunch of effects, like the common knowledge effect, which is the extent to which we exaggerate how much other people know what we know, and as a result, we force them to read between the lines of what we're saying, and there's every chance that they'll get it wrong, and then we'll treat them as idiots because they didn't understand something that seemed completely clear. With the support of Ralph Cicerone and Barbara Schall and others, we've had two Sackler colloquia dedicated to the science of science communication, each of which led to a special issue of PNAS. One came out last year. This is from the first colloquium. One came out a few months ago. These are good sources for people who want to read this literature summarized for a general audience. Also recommend FDA has a risk communication advisory committee that I had the honor of chairing for its first few years. We produced this guideline, free download, trying to make it easy for anybody to do research, to use the research for communication. Every chapter ends with a short section saying how you can evaluate your communications for no money at all, so there's no excuse for not evaluating them, for a little bit of money, and for money that's commensurate, for resources that are commensurate with the stakes riding on good risk and benefit, expected benefit communication. And here's a paper, a technical paper on from that meeting that I mentioned earlier, if you want to look at one set of data that are, that's relevant to this particular situation, which shows one of our results, if you believe our results, shows an enormous gap between what the technical community, on some issues, between what the public health community believe these risks to be and what an extraordinarily well-educated and accomplished group of lay people understood from just following the action in the press. And finally, how do you organize to reduce the risks and increases in expected benefits if you chose to focus your analytical resources on doing a better job rather than imagining that you can quantitatively determine whether the risks and benefits are acceptable? There are many, I think at least all of the English-speaking countries have figures like this one talking about how to organize risk management. This is from our Presidential Congressional Commission on Risk, came out about, 1997. You can see engagement in the stakeholders and as part of an iterative process in the middle. Here's one from the Canadian Standards Association, which I like a little bit better. It shows in the middle a standard management process from initiating the risk, risk management process, preliminary analysis, risk estimation, and so on. I give the Canadians credit. If you can see between each of the stages, there's a four-way arrow, doing a reality check to see whether you've actually done a good enough job to proceed. And so you might not actually get through it if you can't do it. Secondly, it has risk communication connected with two-way arrows throughout this process. So the idea is, so they're saying that you should listen to your stakeholders, your audience, before you even start the analysis so that it's relevant, and you should talk to them so they know what's coming down and they're not blindsided by what happens. For an agency that I view as moving strongly in this direction, I suggest looking at FDA's benefit risk framework, another document that you can download. FDA is restructuring its reporting and to a certain extent its analysis for the approval process for pharmaceuticals around this benefit risk framework. It has 5 factors in the rows. On the columns, distinguish between evidence and uncertainties and conclusions and reasoning, so it separates the scientific judgment from the regulatory judgment. Has these properties, which would be worth considering in terms of developing a benefit risk framework in this area, recognizes science and policy judgments are part of all analyses, quantifies the quantifiable without ignoring other concerns. It highlights ethical and political trade-offs rather than burying them in a metric like QALYs or expected life years lost, which may be appropriate for comparative effectiveness analysis, but not for deciding whether or not something should exist or not. And finally, it supports risk management by showing how you can make even an acceptable product better. FDA has followed up with an IOM workshop report I co-chaired with Bob Bratner, the CMO of the American Diabetes Association, came out earlier this year, and I think has a nice summary of a workshop on communicating uncertainty and assessing benefit and risks of pharmaceutical products. FDA has a strategic plan for risk communication you can download. It's pretty good, and they're systematically working through it. Began around 2007 and has been carried through 2 administrations. Has a statutory risk communication advisory committee that I chaired. We've given FDA recommendations on things like how to deal with emerging events, that is, sort of across FDA's regulated industries. They get signals that something may be going wrong, and how do you do the balance? How do you find the balance between saying, dealing with them too early and too late, and the obvious problems with each of them. So, in conclusion, benefit risk analysis requires socially acceptable, technically sound benefits of risk, which in this case also includes benefit, a strategic focus on a design or decision with proper disciplinary breadth, including the behavioral sciences, and treatment of uncertainty, an ongoing scientifically sound two-way communication with stakeholders, or scientifically sound both in terms of its content and in terms of being based on what we know about human behavior, and finally, organization for transparency and learning. Okay, thank you.
Thank you. Our next speaker is Gavin Huntley-Fenner to talk about the role of human factors.
Good morning. So we'll now drill down just a little bit into the human behavior piece that Baruch referred to earlier. By way of background, my doctorate is in brain and cognitive sciences, and I'm coming at this from a cognitive sciences perspective. I'm going to give a little bit of an overview of human factors and talk about its relevance to risk analysis. I'm not going to give a complete introduction to the field. Obviously, since 1921, there's been a lot of work. So what is human factors? Essentially, it's a study, for the purposes of this meeting, it's a study of the interrelationships between human beings, the tools they use, and the environment in which they live and work. And if you analyze events, failure events, accidents, et cetera, from a human factors perspective, and look at contributing causes. They might be environmental causes, they might be machine or tool-related causes, or they might be human behavior-related causes. You usually find that human behavior-related causes are a contributing factor, either a sole contributing factor or partial contributing factor to the majority of the incidents. And you can look across different fields: motor vehicle accidents, medical errors, and aviation accidents. The human sources of error, of course, are attributable to lots of different, human contribution to accidents are, of course, attributable to error, but they're also attributable to human capabilities. Here the slide focuses on error, and you can see how a particular working environment might lead to fatigue. There's reduced cognitive functioning in PPE, and if any of you, I'm sure some of you have spent time in pressurized suits with masks and gloves, and it turns out there is reduced cognitive functioning. The Army studied it, leading to more errors in basic cognitive tasks. And of course, fatigue is a significant contributing factor to many accidents involving human beings. So it's important to recognize that human error can never be extracted from a system where a human being is involved, and that over time, when we look at accidents going from 1920s to today, we see increasingly that human behavior is a significant contributing factor. On the left here, the data are from motor vehicle accidents, and what's interesting about this particular slide is you notice that although 95% of the incidents involve some kind of human behavior related phenomenon contributing to the accident, often human behavior is interacting with either road environment factors, let's say the weather, darkness, the curvature of the road, or vehicle factors. Your brake fails. Human factors researchers have focused quite a bit on error, and again, be mindful of that error is not the whole story here. But when we do look at error, we can partition errors into lapses that are related to skill or lack of skill, and lapses that are related to slips of mind, failures to remember, misjudgments. And you can see that if you partition error in that way, and there are various schemes for partitioning error, you see that in many cases, this example is from the airline industry, but this is generally the case, that skill-based errors contribute disproportionately to the occurrence of incidents. And in this slide, we also have violations, and this would be sort of knowing controversions of an existing rule. It's one of the classic examples of this, and here I just want to point out the importance of thinking about human capabilities in addition to limitations, is that of a failure involving a Soyuz capsule, which was returning in 1971 from one of the very early Soviet space stations. There was a mechanical problem in which a vent in the capsule failed to close, and they were 100 miles above the Earth, plummeting down. The cosmonauts attempted to close the valve manually, so there was a fail-safe system that required them to intervene manually if in case this error occurred. But the manual closure of the valve took about a minute to execute, whereas the air in the capsule was vented within seconds. So clearly the folks had not sort of thought through the implications of that approach to dealing with this problem. Human factors researchers or safety analysts tend to think about accidents as being a tip of the iceberg. And I think we can conclude, when we think about accidents here in this context, we want to think about fatalities or injuries. The incidents just below waterline might be reportable events, either based on regulatory requirements or lab requirements or particular institutional requirements. And the errors or unreported occurrences, these would be events that are potentially included in a causal chain that might lead to an incident or an accident. Since thankfully fatalities are rare and accidents themselves are rare, we really need to focus on those elements of the causal chain in order to understand if there's a potential for significant safety problem. This has been, this perspective, I think, is reflected in some of the work that's been done looking at high containment laboratories and incidents in high containment laboratories. This is a report from the GAO, which some of you may be familiar with, from 2009, looking at Texas A&M's failure to report to CDC exposures of select agents, power outages at CDC in 2007 and 2008, and the release of foot and mouth disease at the Purebright facility in the UK in 2007. And the GAO went and looked in detail at these incidents, but they also talked to folks working in labs to understand what was the safety climate, and they were able to identify a number of potentially problematic issues that did not rise to the level of safety concerns, except in the post hoc. And so this is just an indication that there are things going on which may be indicative of a safety climate that may not rise to the level of incidents or accidents or fatalities or injuries that you will want to be aware of from a safety perspective. One of the things I've had the pleasure of doing is working with clients, and mainly in corporate settings, developing hazard analyses or risk analyses for all kinds of products or different environments. And this is something that goes on in institutional settings as you're building a new lab, designing a new lab, as you're putting a new project online. And there are some best practices that have emerged over the years for these kinds of processes. And I just wanted to highlight a few of them here from my experiences in human factors. Interdisciplinary teams are really important. It's important to have experts in the room who understand the processes and have data they can bring to bear, but it's also important to have lots of different perspectives, including some potentially naive observers who may be looking at the problems with fresh eyes. The techniques ought to incorporate both qualitative and quantitative data, and Baruch talked a little bit about how that might be done. It's also important to have both structured and unstructured approaches to developing scenarios. A scenario might be a potential failure. What do we have in place to ensure that this potential failure is less likely to occur? And a structured approach to developing scenarios would be, well, let's look at all of the failures in labs like ours over the last 5 years that we're aware of, or let's look at this incident or a potential incident from the perspective of each type of worker who may be present in the facility, or let's look at the potential for incidents associated with arrival, with continuing to work, with completing work at the end of the day, and departing and transitioning out of the lab setting. So those are all examples of structured approaches to developing scenarios. And of course, unstructured would be a sort of a brainstorming approach. You'd expect, of course, that a disproportionate number of scenarios you're looking at are human behavior related. And if they're not, I think that's a clue to you that you may be missing some important issues. The team should be able to toggle between top-down and bottom-up analyses. And in the interest of time, I won't spend a lot of time on that, but it's very important to be able to say, okay, let's stop now, take the 30,000-foot view. Have we captured all of the big concerns? And at the same time, be able to get into the nitty-gritty of a particular process or task that may be of concern. I wanted to just briefly talk about some of the tools that are used, and in particular, a risk rank matrix is an example of a tool that many of you will be familiar with, where it helps you organize potential scenarios in terms of their severity and likelihood, and the most severe, most likely scenarios are going to be ranked as the most concerning, and the least severe, least likely ones will be of less concern. And you want to, of course, pay attention to the most likely and most severe occurrences. The threshold where you divide these are the things we care about versus these are the things we are not going to look at right now, it will vary from context to context. And what's been interesting to me is to look at how these matrices actually reflect the values of, or the priorities, or the risk tolerance of the institution, company, team. In some cases, you might have a system-wide consensus, okay, this is going to be our threshold for tolerance of risk. And that may be based on things like, well, we're assuming that we have 20 projects going on at 3 or 4 BSL-3 facilities under our auspices, and so as an institution, we are going to set our threshold here, given that the more projects you have going on, the more likely there is to be an incident of concern. Of course, the benefits of risk assessment from a human factors perspective are many. I think just a couple I will highlight right now on the very bottom, that they help to sunshine implicit risks that have been adopted by the team. And they also sunshine hidden or underappreciated benefits of existing practice. If you have anyone who's questioning, well, why is it that we do X, Y, or Z? Well, this process will actually help to sunshine that. And frankly, this was mentioned yesterday, biosafety, that is having a robust program for identifying lapses that may fall in the safety rather than the security realm, can actually harden your target from a biosecurity perspective, and they're desirable for both biosafety and biosecurity perspective. Simple approaches can yield significant results, and this is just an example. You remember, folks may remember the IOM to Err is Human report from 2000, which I think found something on the order of 44,000 to 98,000 fatalities related to hospital errors and potentially 1 million injuries a year. This is in American hospitals related to hospital errors. And they looked, since then folks have looked at the kinds of things we can do to reduce errors in hospital settings. A simple surgical checklist is one such example that's had a significant impact on reducing errors. And then finally, my very last slide here, I think it's important to recognize that in addition to risk from a project point of view or from a lab point of view, we may want to think about risk cumulatively from a system-wide point of view. Human beings tend to underestimate cumulative risk. We tend to be overly optimistic about our capacity to control local risk. And so it's going to be very important for us to think about how it is that risk accumulates across projects system-wide and potentially nationally from a public policy perspective at the federal level. And then finally, we also should be aware of our inclination to look at the accrual of benefits from a very local perspective and externalize the risks that are borne by the community at large. Thank you.
Thank you. Our next paper will be by Monica Schoch-Spana on ensuring public engagement.
Thank you very much to the organizers for inviting me to engage in this particular conversation, and thanks for some wonderful presentations that have deepened my knowledge of the issue. I am here to talk about what I consider to be an integral step in a credible and comprehensive risk-benefit assessment of gain-of-function research, which is engaging the public. And I want to discuss that issue by way of 4 questions, very simply. Who is the public? What do we mean by engagement? Why is engaging the public valuable? And what are some considerations for NSAB, NIH, and our workshop attendees here today to take into mind? So let's start with that first question of who is the public? So in the broadest sense, and relying on the democratic philosophy of John Dewey, the public very simply comprises people who are interested in or affected by gain-of-function research governance decisions. Of course, who's in that group depends on your perspective. Political jurisdictions, complex disease processes, and many, many other factors complicate definitions of the public. And I'll just illustrate that with a few global, national, and local publics that are relevant to this particular debate. In the sense that most scientific and medical experts in this workshop, the public is that population of individuals who could become ill or die due to infection with a pathogen of pandemic potential, whether it's through natural, accidental, or intentional means. And in the pandemic context, this kind of public, the population at risk, is global, immunologically naive world citizens in the abstract are equally in danger of infection, and they're equally in need of medical countermeasures, potentially informed by gain-of-function research or alternative means. Arguably, though, additional publics reside within this global health public. As Paul Farmer and others demonstrate, inequalities across and within countries, quote, structure not only the contours of the AIDS pandemic, but also the nature of outcomes once an individual is sick with complications of HIV infection, just to close that quote. Now, coming back to the U.S. context, Sandra Quinn and colleagues propose that U.S. racial and ethnic minorities were at a threefold disadvantage during the 2009 H1N1 influenza pandemic. They faced enhanced exposure to H1N1 virus due to social, economic, and behavioral elements. They face greater susceptibility to flu's complications because there's a high prevalence of chronic disease and immunosuppression within that population. And they faced impaired access to timely and trusted health information, vaccination, and treatment. So let's leave public health aside for a moment and just think about other national publics that come to mind in the U.S. context. While Congress may authorize and the NIH may invest finite dollars for science, ultimately the U.S. taxpayer underwrites the cost of government-sponsored research. This U.S. public, too, confers authority and operating budgets on federal bodies implicated in the biosafety systems that have been created and continue to be refined that are to keep researchers and the larger public safe in the context of gain of function and other research of concern. So global, national, now let's go down to the local level. This is another potentially relevant public. Though it is the place-based communities that actually host the facilities where gain of function research is conducted. In the case of a laboratory release, these people could be on the front end of an emerging pandemic. As a result, they have a strong and direct interest in the biosecurity and biosafety systems to avert any release, and should prevention fail, they also have a direct interest in locally robust systems to treat the sick and interrupt transmission. Now, expansion of high containment labs in the U.S. has already elicited a range of public reactions from broad support to organized opposition. And that organized opposition has stymied the building of certain proposed facilities. Now, not confined to perceived public health threats, motivators for local resistance have also included issues of environmental justice, community empowerment, and urban development. So, even this very short list of publics suggests some basis for potential engagements at global, national, and local levels, and it suggests that the terms of the debate may be broader than what has unfolded here over the last day and a half, with some exceptions scattered throughout the conversation. Now, what do we mean by engagement? That phrase usually refers to the processes by which citizens influence the policies and programs that affect them. And in a democracy, people have a variety of means to make their voices heard. We can vote, we can write letters, we can lobby, we can demonstrate, and take other collective actions. But over the last 50 years, there are more direct means of public participation in the decision-making process itself. Those means have developed as citizens have become less deferential towards authorities. Public policy issues have become more complicated. The theories of deliberative democracies has flourished, and practical experience in participatory approaches has accumulated. Now, scholars and practitioners usually talk about public engagement as a flow of influence and information between authorities and constituents. So I'm going to just give you a very simplistic continuum to show that there are different kinds of public engagement: communication, consultation, and collaboration. Operating in the communication mode, This is when an official or an agency conveys information to members of the public in a one-way fashion, often with the intent of educating and informing the public. Now, public feedback's not required, not necessarily sought in this particular modality. And in the case of the gain-of-function research debate, this could take the shape of press releases, educational websites, a summary report, such as in the proceedings of meetings like the last 2 days. Now, in the consultation mode, this is an interaction where authorities solicit opinions through surveys, polls, focus groups, or during a public comment period such as that mentioned for the NSAB report by Dr. Stanley. Again, this communication is one way, but it's from citizens to authorities. And so the public's points of view, criticisms, constructive advice can inform policy options, but their input is just one of many that decision makers take into consideration. Now, the third approach is considered to be, as Baruch had talked about earlier, a two-way flow of information and influence between citizens and authorities. And it's about dialogue fostering better understanding of a very complex problem from all sides and perspectives. So this type of public engagement allows an opportunity for collective learning as part of honest, respectful interaction among authorities and diverse constituents, and for those iterative exchanges, such as Baruch had indicated earlier, that are necessary to approach policy concerns that are technically and ethically complex. So let's get to why is engaging the public valuable? Now, theoretical discussions have offered substantive, pragmatic, and normative rationale to justify co-production of policy decisions that involve the public. There is a great summary in the 2008 National Research Council report, Public Participation in Environmental Assessment and Decision Making. And that committee identified three important justifications for deliberative processes, and they include improving quality, enhancing legitimacy, and building capacity. So let's talk about that. Improving quality, what did the committee mean? And what did the evidence that they review suggest? That public participation, that is that collaboration or intense form of public engagement, enhances decision quality by getting what a number of NRC reports have said, the science right. People who are not typically considered experts nonetheless hold local knowledge that is sensitive to context. So their grounded input has often corrected technical analyses that have been misapplied in local conditions. Now, second, public input, not encumbered by technical presuppositions, that is the fresh eyes that Gavin had indicated, can prompt new lines of inquiry that in the end improve technical competence of policy decisions. Enhancing legitimacy, what's going on here? Well, participation can serve as a venue to inform and elicit the consent of the governed on complex issues in ways that traditional methods like elections really can't provide. So participatory, deliberative forms of engagement, when performed in good faith, can help build trust between officials and the public, enable officials to consider different points of view, including those of otherwise disenfranchised people, and importantly, provide evidence even to dissenting participants and non-participants that officials have indeed acted in a fair and accountable manner. Building capacity, what's the value there? Well, if public participation is executed well, it builds a foundation of trust, mutual understanding, and practical experience with dialogue that can benefit future policy formulation, implementation, and evaluation. So the public derives greater facility with the science and the political process, and scientists and governing officials develop a better understanding of public concerns. That deliberative exchange helps scientists citizens, and governing officials understand aspects of a problem that go beyond their immediate circumstances, and it provides the opportunity for refinement and even the changing of opinion. Now, there's a fourth cross-cutting justification for public engagement, and that is navigating uncertainty, which Baruch and Gavin both pointed to. This has been proposed particularly in the case of science and technology policy. So, involving the public can strengthen the capacity of civil society, technical experts, industry, and government for analysis and reflection on the uncertain and ambiguous nature of many scientific and technological developments. Judgments informed by scientific fact and social values are necessary in the context of unforeseen consequences that can be good, they can be bad, they can be in between. They can also unfold for decades or more. The benefits of public participation in technically complex policymaking are not merely aspirations. And there's the evidence that this particular committee looked at included about 1,000 empirical studies, practitioner reports, and theoretical analyses from across the social sciences. So, let me conclude with a couple of considerations for NSAB, NIH, and conference attendees. I think there are two issues that merit further attention if broad public engagement is a feature of the proposed gain of function, benefit, and risk assessment. These two things are nested engagements and enduring structures. Broad publics at local, national, and global levels exist. And you're sitting there thinking, practically, where does one begin? I'm sure. The U.S. already has precedents involving the national academies and others for public engagement exercises that are national in scope, diversely populated, and involving technically and ethically complex health security matters, such as how does one distribute scarce medical resources in the context of an influenza pandemic. Now, one could consider holding deliberations in communities hosting gain-of-function laboratories, as well as populating that national conversation in a way to address the health disparities aspects of risks and benefits. NIH, federal partners, national academies, and other interested entities could also encourage their counterparts internationally to develop comparable deliberative processes. It's interesting to note that in 2009, a citizen consultation on climate policy was conducted simultaneously in 38 countries. I'm not suggesting we do that, but transnational consideration of a transnational public health problem seems a reasonable goal to at least consider. On the matter of enduring structures, public engagement on the issue should not be limited to a one-and-done performance, though planning for an exercise to meet the NSAB timeline can certainly happen in the short term with the right input. Engagement mechanisms on this specific issue can serve as the foundation for the development of deliberative systems to tackle analog dilemmas that are certain to emerge in the future. Such participatory endeavors and the diffusion of well-crafted communication products emanating from them are an investment in democratic governance in an era of accelerated bioscience and biotechnology developments. So we're talking about efforts that would enhance the scientific literacy of citizens, as well as the capacity of scientists, their sponsors, and their regulators to represent their respective work in broadly meaningful ways. I want to just conclude with one sentence, and I'd like this to be the takeaway that how a decision is made is just as important for many people as the outcome of that decision. So thank you very much.
Thank you. Okay, our final set of presentations are by Ralph Baric and Robert Lamb. I don't know if both of you want to come up at once or if you're tag teaming it, on what, if any, special considerations about GOF research need to be taken into account in the risk-benefit assessment.
I'd like to thank the committee for inviting me to speak. I'd just like to note that my research includes studies on coronaviruses, noroviruses, flaviviruses. We look at virus-host interactions, susceptibility allele mapping, cross-species transmission mechanisms, pathogenesis, and animal model development. And as some individuals have been tweeting about the speakers in terms of their funding or patents, I will state that I'm well funded by NIH. I have patents on coronavirus reverse genetics, vaccine design, dengue virus reverse genetics and vaccine design, and norovirus vaccine design. I don't have a beach house overlooking the ocean. I do have several nice plaques from the university, so that's my income. Yeah, maybe next year. So the goals of the talk are to talk about differences between coronaviruses and influenza viruses in terms of their distinct biological organisms, and to indicate that concepts or outcomes described for flu may or may not be relevant for coronaviruses, that gain-of-function experiments encompass a very diverse set of experiments. These include experiments that are critical for vaccine and therapeutic design, pathogenesis and virulence, virus-host interaction networks, susceptibility allele mapping, and host response patterns that drive pathogenic or protective responses, as well as those how host antiviral defense networks are programmed during infection. And all of these basic studies are really engines for the development of broad-based vaccines and therapeutics for the future. Transmissibility studies actually fall in a different category, although in of itself also functions as an engine for the development of broad-based vaccines and therapeutics. And so as regulations develop, or if they develop, hopefully they'll be framed to appreciate the biological differences or complexity that exists between viruses. So Bob and I are sort of charged with talking about differences among organisms, what functionality is being gained or lost, are transmissibility, virulence, growth, and functionality all similar in terms of gain-of-function objectives, and any special considerations. And so in the context of that, I'll give a really brief introduction about coronaviruses. I'll talk about coronavirus cross-species transmission and how receptor interactions mediate that using SARS and MERS as models. I'll talk a little bit, in the context of that, I'll talk a little bit about transmission using mouse models, as well as discuss the difficulty in developing transmission models for coronaviruses. In the context of this sort of cross-species transmission discussion, I'll talk about ethical alternatives. And I'll also talk about some intangibles and unintended consequences that might occur as a consequence of regulation, reminding you all again that we don't have any vaccines or therapeutics for SARS or MERS. So when you think about emerging coronaviruses, you go back around the time of Columbus, and current phylogenetic estimates suggest the first human coronavirus, NL63, arose in the New World around 500 to 800 years ago from bats. Around the 1700s, a human coronavirus 229E emerged in Africa, probably from bats. Human coronavirus OC43 emerged around the turn of the 20th century, most likely from cattle, probably via rodents. Porcine epidemic diarrhea virus emerged in northern Europe, most likely from bats. Around 1982, it caused disease in pigs, spread slowly across Europe until it arrived in China around 2000. Super highly pathogenic strains emerged, which caused massive economic losses in the swine industry in China. It arrived in the US in 2012 and has killed 8 million pigs since it arrived, so don't underestimate the pathogenic potential of an emerging coronavirus. Human respiratory bovine coronaviruses emerged about 20 years ago. SARS coronavirus about 10 years ago, and MERS 2 years ago. So if this looks like an increasing pattern of emergence, that may or may not be true. It might be better surveillance. We really don't know. Clearly, these viruses have the capacity to move between species. And in the SARS paradigm, the virus was thought to emerge from bats, move into civets, and then into humans, and this set up a transmission cycle that drove the expanding epidemic. Other models argue that it went from bats to humans and then went to civets, and this set up an expanding epidemic. But basically, there was more evolution towards efficient usage of the human ACE2 receptor. And so the Chinese did a marvelous job of sequencing animal and human strains during the expanding epidemic. And so the animal strains up here include civet strains, SC16 and HCSC6103. And then human strains during the early, middle, and late phase of an epidemic. And you can see wherever there's color change, there's a change in the amino acid sequence across the genome. And all in all, there's about 16 mutations that were associated with the expanding epidemic. We know the functions of 3 of those. 2 mutations at 479 and 487 increase the efficiency of the civet strains to use the human ACE2 receptor. Here's the receptor binding domain. And so these mutations allowed the virus to be able to interface with the human ACE2 receptor. Mutations in the M-glycoprotein enhance virus yield per cell. If you take human airway epithelial cells from transplant recipients, from the lungs of that were removed from transplant recipients, and grow them on liquid air interfaces, those cells take on the architecture of the human airway. SARS likes these ciliated airway epithelial cells here. The ACE2 receptors expressed on those cells, and you can see that these human early, middle, late phase epidemic strains grow really well. The civet strains don't grow at all. Interestingly, if you take the human Urbani strain, it can't grow on mouse cells, but if you express the human, the civet, or the bat receptor, this virus grows just fine. And so in its evolution, and for maintaining its capacity to replicate and cause an expanding epidemic, the human strains had the capacity to use the civet receptor, to cycle through civets, and actually after most likely retreat into the bat reservoir following control of the expanding epidemic. Now you can redo this experiment in the laboratory. Here are the human strains replicating and expressing their nucleic capsid protein in these airway epithelial cultures. The civet strains don't replicate at all. But if you take the SC16 strain and you leave it in these cultures, you begin to get mutations that occurred during the SARS epidemic at position 479. But by day 8 and day 22, you get mutations at other receptor interface sites at position 444 and 472. So a different set of mutations evolved in vitro as compared to the 2 critical mutations here that evolved in the expanding human epidemic. These mutations allowed the virus to replicate up to 10 to the 7th in these cultures. And if you look at their ability to use the civet receptor, human epidemic strains use the civet receptor fine. The civet strains use the receptor fine, but these in vitro evolved strains can't use the civet receptor at all. So these viruses actually used a totally different pathway to adapt to the receptor. And so in most instances, when we're looking at receptor interactions with coronaviruses in vitro models or in vivo models in a different species, where you passage in that species, you actually, in this particular example, you gain human ACE2 receptor usage, but you lose civet ACE2 receptor usage. If you do the same experiment in a mouse, you gain mouse ACE2 receptor usage, you lose human ACE2 receptor usage. So if the central sort of issue in the influenza transmission model studies is that there's an identity in terms of the receptor. As a virus moves from avian strains into mammalian strains, they use the 2,6 receptors. The receptor is virtually identical in ferrets and humans. And so if you select for increased 2,6 usage in one species, it can oftentimes select for increased 2,6 usage in another. And so the debate sort of centers around the fact that if you can select for increased transmission in one species, then because the receptors are identical or nearly identical, this results in increased transmission in the other. This is a very different paradigm that occurs in coronaviruses. Coronaviruses use the ACE2 and ACE2 ortholog receptors for interaction and to enter into cells. And anywhere there's a color here indicates that at the receptor interface residues that actually bind the virus, there is sequence variation. So the interface between the human or the civet or the mouse or the ferret is fundamentally different. as you move from one species to another. So, for example, there are 8 changes in the civet interface binding residues, 9 in the mouse, 9 in the ferret, and less in different bat ACE2 receptors. So while it's possible to select for generalists that can efficiently use multiple ACE2 receptors, again, when you do in vitro selection or in vivo passage, you usually end up selecting for a variant that's a specialist that can only use one receptor. And here's a good example of this. This was a slide that I showed yesterday. SARS replicates poorly in the mice. Contasabaro and A.J. Roberts selected SARS strains that could replicate more efficiently in mice. And here are the mutations that occurred at passage 15, 20, and passage 25 by another group. Notice that the number of mutations at the spike receptor binding interface go from 1 to 2 to 3 as the virus is passage longer in the mouse species. In addition, you have mutations in the M glycoprotein, NSP13, NSP9, and NSP5 that also occur with increased passage. Let's look at the receptor interfaces. So in the case of the MA15 strain, the virus is adapting to mouse residues at the interface, and so it handles clashes that exist between human strains and these 2 mouse receptor binding residues that are different on the mouse ACE2 molecule. In the MA20 strain, it's using the other side of the interface, where it's removing a bulky group so this 479 mutation can interface with variant mouse residues that are in the ACE2 receptor that are different from human at this location. And in the MA25 strain that's most well adapted to use mouse, it actually changes both interface binding sites, so it really grabs on and firmly holds on to the mouse receptor. This increases the ability of SARS to bind to the mouse ACE2, and especially in the MA25, generally loses extensive fitness for binding to human ACE2. If you isolate the S mutations so that they're only in the wild-type SARS backbone, they will not kill mice. So S by itself is not essential, is not the only gene necessary for expanding virulence. You actually need 2 or 3 other mutations to mediate that phenotype. So with this increased replication and virulence that occurs in mouse, will this result in increased transmissibility in mice? We're going to go to an outbred model of human populations again. I showed this slide yesterday. This was the collaborative cross-mouse resource. It was made from 8 founder lines from Castaneus musculus and domesticus substrains of mice. We made the 64 F1 diallele crosses, so they were genetically an F1 population, sort of a model of an outbred human population. We aged them for a year so that they'd be highly vulnerable to SARS infection. We vaccinated half, and then we challenged with virus. So this is about 1,800 mice. And then we co-house these with uninfected animals. That should be uninfected controls, about 600. So we had 3 infected and 1 uninfected mouse that were co-housed following infection for 5 days. Now, by using an outbred population, we have extremely different susceptibilities to infection. In young mice, the LD50 from some of the founder strains is 10 to the 2nd. In other founder strains, it's 10 to the 6th. In old 1-year-old mice, the LD50s for almost all the strains are below 10 to the 2nd. So what did the data look like? Vaccinated and unvaccinated animals had very high titers of virus. Unvaccinated animals, none of them had virus. A handful of these controls we actually sequenced with using RNA-seq, and there was a complete absence of viral RNA. So increased virulence and replication, at least in this model, where the number of infectious viruses that are needed to that are very minimal to infect animals in the population did not occur. So what about SARS transmission models? They haven't been established or attempted by the field. SARS doesn't replicate in the guinea pig. SARS does replicate in ferrets, and it causes limited disease. There's inefficient usage of the ferret receptor. Is it possible to establish a model? I think it likely could be established. You could select for receptor mutants that enhance the ferret receptor, ACE2 receptor. And you could probably do this in a way that it would result in a concomitant loss for the ability of these strains to actually bind or use the human ACE2 receptor. If you used Ron's or Oyoshi's approach, you could probably select for transmission strains that would involve mutations either in the spike and or other genes that would probably also drive it further away from the human ACE2 receptor. So the model would be quite different. In the case of the flu system, where you have receptor identity, in the coronavirus system, you have receptor variants at the interface site. And so it would likely be safe. You could specifically drive conditions so that you could select for specialists. And then it would be fairly easy to evaluate directly and determine with proof whether it could use the human receptor. And in human ACE2 expressing transgenic mice, ask the question whether it would cause disease. I'm not advocating doing the experiment, but I got pushed on it yesterday, so I thought I'd answer the question. Is there value in these transmission studies? I think this type of SARS coronavirus model system would be relevant for the ferret. You would identify key phenotypes associated with enhanced transmission. And as Ron and others have said, I think you could establish biochemical screens that you could look for phenotypes associated with transmission, with enhanced transmission. How would they be applied? I think it would be certainly relevant for the pre-pandemic strains that I mentioned yesterday in the talk. So I can see an advantage for that. I think understanding fundamental insights into mechanism of emerging transmission is important. I've talked to various modelers who argue that such data would be critical for modeling epidemic potential. It would give you some hard metrics of receptor usage, and it would reduce some uncertainty. And I think it could result in new strategies to improve safety of live attenuated vaccines that would be prevented from being transmission defective viruses. Now, in the context of animal model developments, I want to give you one example of an alternative in vivo model that was developed as a safe alternative to using SARS mouse models, since that was one of our charges. And this work was done in collaboration with Susan Baker's lab. She really led it. She was interested in developing a safe model, a safe alternative model for identifying drugs that blocked coronavirus protease genes. And she was going to use Symbis as a non-pathogenic alpha virus as the model system. Into the Symbis virus, she was planned to insert the PL protease gene of SARS downstream from ISG15, which I'll talk about in a little bit. So what is PL-PRO? It's a target for protease inhibitors. It mediates removal of ISG15 from cellular proteins. It's an antiviral defense program. There's a very simple in vitro screen for the activity. If you can insert this construct into alpha viruses, you could inoculate interferon defective mice and get an easy reporter assay. And so she did this. In this case, if you place this reporter, this virus is non-pathogenic in wild-type mice. If you place this in the IFNAR mice, and the ISG15 is expressed, and the protease is expressed, the protease removes ISG15 from cellular proteins, and the animals lose weight, and most of them die. If you knock out the activity by inserting a mutation in the protease, so it can't cleave ISG15 from cellular proteins, the animals survive. Very simple screen. Now you can drop in drugs. So she dropped in the 3E protease inhibitor and now phenocopied the attenuated phenotype. So in this case, the drug blocked the protease gene from removing the ISG15 molecules, and the animals survived infection. So how well did that work compared to in vivo models? Well, here's SARS in mice, mouse-adapted SARS in mice through 4 days. The animals lose over 80% and succumb from infection. Mock drug-treated controls don't lose any weight. If you treat animals with poly-IC to induce an immune response, all the animals survive. If you treat with drug and MA15, all the animals die. Why? The virus tropism between the two models is different. Symbis likes to go to the CNS, coronaviruses go to the lung. Bioavailability of the drug could be different in the two compartments. Virus titer in the two target organs could be different. The in vivo targets of infection can be different. And so these kind of indirect models can result in misinformation that can complicate downstream drug development. Talk a little bit about MERS. The receptor for MERS is DPP4. It's a high affinity for camel and certain bat TPP4s. MERS can't use the mouse, rat, ferret, hamster, guinea pig receptor. And it can't use that because there are mutations right at the receptor binding interface. Just like in different SARS ACE2 molecules, there's a tremendous amount of variation in receptor interface residues between different species. If you take this block of human sequences that encode these 5 mutations and drop them into the mouse DPP4 molecule, now these are human DPP4 infected with a MERS strain encoding red fluorescent protein, can infect DPP4. If you put in these human residues, it infects just fine. Well, that's great. So one of the things that we've talked about here is that you can use sequence information to do prediction. So we worked with 3 different groups based on these data and predicted 10 mutation sets that would enhance this interaction between the MERS RBD and the mouse DPP4 receptor. And we made them in the laboratory, and all of them failed. So while it's possible to use structures to predict pathways, many of the times this actually fails. It doesn't fail all the time. And so there are examples of where you can use structure-based prediction, but oftentimes it fails. So why did it fail? Well, here are the 5 mutations that enhanced usage of the mouse receptor. If you put these human residues in the mouse backbone, virus grows fine. And you could break down different amino acids, and it turns out amino acid 330 and amino acid 228 encode most of the phenotype. So it turns out that amino acid 230 actually removes, when you put in the human residue, it removes the glycosylation site that's present in the mouse molecule. This is a big blocky carbohydrate that prevents the virus from engaging the mouse receptor. So there's really 2 ways to make a mouse-adapted strain. One is a transgenic mouse expressing human DPP4. The second is to use CRISPR-Cas to introduce those changes into the mouse DPP4 receptor. You look at the guinea pig and the ferret, which are used for transmission molecules studies. You have these glycosylation sites that exist as well, which would prevent virus receptor usage. So in terms of MERS coronavirus transmission models, these again have not been developed or attempted to my knowledge. It would be very difficult, but it's not impossible to establish, and the biosafety concerns are much more uncertain as it would be compared to with SARS, where we know we could drive the system to use only the ferret receptor. So I want to finish with two last slides to talk about regulatory intangibles. This first slide was sent to me by Julie Pfeiffer, and it was in the middle of conducting a survey on the effect of the pause and on the future plans of trainees in flu, SARS, and MERS research. There have been about 126 respondents so far. 79% study viruses, 52% study respiratory viruses, 70% want to study some the respiratory virus in the future. About 95% of these students have heard about the debate. 37% are less likely to work on SARS, MERS, and flu research. And about 53% have changed or may change their plans in the future to move away from this area of the field. And finally, I want to talk about the subtle effects on grant review processes. GOF restrictions are currently designed to limit animal model development, reverse genetic applications, and limit the ability to make causal associations between genotype and phenotype. And so this uncouples a very powerful experimental continuum that's important for developing a highly competitive research proposal that uses biochemistry and structure function studies to be supported by genetic studies that validate and demonstrate causality of the functions of mutations, and then to be able to take that into viral pathogenesis studies, virus-host interaction studies, and then perhaps use that data to translate into new vaccines and drugs. And so if these restrictions are too powerful, you really will uncouple the ability of people to put together grants like this that would be very powerful. And this would have a subtle, long-term deleterious effect on the field. And so with that, I thank you for your attention.
Thank you. Okay, Dr. Lamb.
Thank you. I'm going to be very brief because nearly everything that I have to say has been said, if not once, it's been said twice already in this meeting. But I thought we'll just step back for a moment, and that is in 1999, when Yoshi Kawioka's group and Peter Plazy's groups, by slightly different methods, established reverse genetics of negative strand viruses in a way that was highly efficient. It had been done inefficiently 10 years earlier by Peter Plazy. And Yoshi Kawioka published his paper in 1999 in PNAS, and Andrew Pekos, Biao He, and myself wrote a commentary on that achievement. And we wrote then in the very last paragraph of the commentary, along with technological advances such as the ability to recover designer viruses, relative ease of constructing influenza virus genes from synthetic oligonucleotides, and the sequencing of genes from extinct, that meant 1918, influenza virus strains such as the highly virulent 1918 Spanish influenza virus strain, which of course has now been done, comes a responsibility to avoid the construction of viruses that may pose a public health hazard. Restraint should be practiced, especially when dealing with factors associated with increased virulence, such as hemagglutinin proteins with multibasic cleavage sites, or in the use of neuraminidase subtypes known to confer trypsin-independent cleavage of the hemagglutinin. Well, that was 15 years ago, and now we've come a long way since then, and of course we have select agents in terms of the 1918 virus that's been recovered from Taubenberger's sequences by Peter Plazy's group. I think it's worth realizing this is not really a new topic. This has been going on now for quite a long time. I hope that's forward, yes. Now, I just give two examples of previous gain-of-function experiments. One is the polio attenuation for live vaccine development by Sabin. You can look at this in two ways. Some of you might want to call this gain-of-function, which I would, because now we have a virus that's no longer neurotropic and has mutations in it that affect the host cell factors that bind for translation. Others might say this is loss of function because, in fact, the virus is no longer neurotropic. So you can look at it in two different ways. The other one that's worth mentioning out of a list of hundreds is serial passaging of influenza virus WS, the first influenza virus ever isolated by Wilson Smith, Laidlaw, and Andrews in 1913. This was a human influenza, it was Wilson Smith's own virus from his own throat, and that virus they decided they needed a small animal model. And what they did was to go back actually to the polio literature from 1911 and passaged the WS human virus in the brain of mice to get two viruses, one called WSN, Wilson Smith neurotropic, and one called NWS, which was neurotropic Wilson Smith. And they both killed the mice. Now, making the mouse model for influenza possible, this, in fact, is, I would describe as a gain-of-function mutation. Now, we've been asked to comment about mitigation in this session. There are various ways you can mitigate the influenza virus. One would be to use virus with drug sensitivity, provided you're not trying to study drug resistance. You can vaccinate to use a strain that, in fact, has a genetic backbone such that you can vaccinate, if possible. You can use an existing virus where immunity is widespread, such as with the pandemic 2009 virus. You could use a mutation that confers acid stability, and I refer people to Charlie Russell's papers on this. You can make a mutation in the HA basic cleavage site so that it was no longer readily cleaved inside the cell. But of course, that depends on the gain-of-function mutations that you're seeking and would not be appropriate for the Ron Fouchier and Yoshi Kawioka experiments. And then lastly, which has been mentioned, I think, at least twice before, is the microRNA-based strategy to mitigate the risk of gain-of-function, which comes from Ben Tenover and was published in Nature Biotechnology in 2013. It's been widely talked about and shown at least twice here at this meeting already, and Mark Lipschitz shows his own data for this, that he published a paper in which he suggested alternatives that could be used. And these, and I've selected just a few of his long list. He showed the table that was very small. Molecular dynamical modeling of influenza virus proteins and interactions with inhibitors and receptors. In vitro studies of specific properties required for human adaptation using single proteins. In vitro studies of genetic interactions between loci in one or several viral proteins using replication-incompetent viruses and worrying about epistatic interactions. Then sequence data comparisons of genetic properties of human and avian adapted viruses. And lastly, comparisons of human seasonal isolates and zoonotic isolates from infected human and avian isolates. The problem that I have here is that I don't think any of these types of studies give you the information you get from an animal study. I really think that, in fact, to understand the pathogenicity of influenza virus properly, you would have to work with an animal system. And probably the best model we have at the present time is the ferret. And I don't see any alternative to doing that, doing the ferret experiments. And of course, with that comes a higher risk of dealing with a virus, what would happen should it escape. I was asked to comment about differences among organisms. Mice do not sneeze is a popular opinion, but apparently if you observe mice at night, they're nocturnal, of course, they do have, infected mice do have some form of respiratory symptoms. Another virus that is a mouse pathogen is Sendai virus, a paramyxovirus, and it is reported at least to spread by the airborne route in mice. The other differences among organisms, of course, is we have very different innate and humoral immune systems. The bat, which is 20% of all mammals that we know about, or greater number, have a very different immune system from humans. And indeed, many viruses that we are now discovering are in fact endogenous to the bat population. And so there's this coexistence of bat viruses with the bats that we don't see with humans. So there are tremendous differences between different species that I think have to be taken into consideration in these types of analyses. And then I was asked to comment about transmissibility, virulence, growth, and functionality for vaccine production, and whether they're all the same or not. And this is a complicated issue, I think, but they're overlapping circles. There are places where this is the same or not. Growth may not be gain of function, or it may be a gain of function, but it's not necessarily bad. Obviously, for vaccine development, we're looking for growth, but that doesn't affect virulence. There's in other cases, in fact, growth and virulence may be tightly coupled. So these are very much overlapping circles that have to be investigated depending on exactly what experiment or one strain of influenza virus one is dealing with. And then there are other matters to consider. And that some of these are more personal in terms of things that I've listened to at this meeting. I think that we should modify the mantra that gain-of-function research is useful for vaccine development and antiviral drug development. It's sort of the throwaway line. It's like the high school essay that everybody must have written at one point or another, where you're asked to write about the dream, and the last line of the dream is, "I fell out of bed." It's that sort of pathetic ending. And I think that with saying, this, of course, whatever you're doing would be important for vaccine development and antiviral drug development, is getting overused and oversold. I think Dr. Kawioka gave a very thoughtful discussion yesterday of how, in fact, his gain-of-function mutations can affect vaccine development. But, of course, it's not a proven case yet. The second comment that I'd like to make, that seems to be lacking in occasions, but I've had to experience it myself, and that is the biosecurity concern about a rogue, perhaps bipolar, it's not clear, graduate student or postdoc who removes adapted H5N1 from a BSL-3+ lab. And that is, we have a lot of things in place to try and make things safe and secure. But the one thing that it seems to be very difficult to mitigate against is a crazy person who wants to take virus out of a lab when it was being grown, for there's no accounting for how much is produced at that period of time, and then disseminate it somewhere else. And I think it's the major problem in terms of risk assessment is figuring out, in fact, where things are coming from, and that, in fact, very often it could be within ourselves, meaning within our own research groups. And the last comment I'd have to make, and that is one that I think that worries me and a concern, and that is that the institutional biosafety committees vary enormously in competence. We heard from the University of Wisconsin yesterday about a highly competent system that has been set up with a purpose-built laboratory. But I think many other universities have much less expertise at designing safety protocols for investigators. And therefore, I think that the very high-risk experiments, which I notice we have not defined, we keep on talking about the 10 to 15 experiments that are really of the high-risk category, that they, in fact, actually need to be defined, and they should actually perhaps be considered by a national panel, similar to, in fact, what was set up for the RAC. And I think that would solve a lot of problems. And so with that, I'll be happy to answer any questions.
Thank you. Let me ask all the morning speakers to come up here, and we now have about a half an hour for general questions, and line up by the two mics, and we'll rotate. Okay, on my left.
My name is John Gardenier. I was highly involved in risk analysis in the 1970s and 80s, specifically with regard to maritime transport of hazardous chemicals and the dangers those pose to shoreside populations. I learned a great deal at that time from Baruch Fischhoff, who was even then one of the sterling lights of the early days of risk analysis. And I'm glad to see that he's still serving that function today. There are several things that concern me over what I've heard about this area over the last couple of days. One, I don't see any of the complexity of analysis that Baruch illustrated in his talk, where you have very well thought out network diagrams of the considerations that are involved. What I've heard is a great deal of concern about risks, but not very well structured and not very well quantified. In fact, there seems to be some consideration that gain-of-function research might be vastly more successful than any other scientific endeavor that I've ever heard of, resulting in a threat to the entire global population that is virtually instantaneous and contains potential for 100% lethality. And on the other hand, I hear vague references to benefits in speeding vaccine development without any scenario associated with those or any quantification of what might be involved. I was very glad to hear the discussion of human factors, which turned out, not surprisingly I'm sure, to be the central element in maritime risk analysis, as in virtually every other field of risk analysis. I was also very glad to hear about engaging the public. My wife and I, who both have backgrounds in risk analysis, may be the only members of the public attending this meeting. So in terms of outreach to the public, which everybody seems to agree is desirable, there's very little of that happening now. All right. All of this is intended to try to point out that, as was outlined in the introduction to the meeting yesterday morning, this is the very beginning of what it will be a long and complex process over the next at least 12 months to try to come up with a useful, systematic, and well thought out way of dealing with the issues here, risks and benefits in gain of function research. I just want to point out that the speakers in this session have outlined very important aspects that need to be built into this work, which are not present right now. And that's understandable at the beginning of the effort, but
Let me have the panel react to your comments, and
they have to come in before you finish.
let me also ask subsequent questioners to phrase your question as a question. Panel?
Well, let me start by thanking John and returning the compliment, which is and I was learning about this field as it was emerging. And an influential paper was one that John had done as head of research at the Coast Guard, which I think captured the dynamics and complexity and subtlety of some of these problems. So John was looking at, see if I remember this correctly, at the accident rate associated in intra-coastal waterways associated with the introduction of ship-to-ship radar, and found that it went down surprisingly slowly, even though we had a big advance in technology. And what John deduced was that it was because when nobody had radar, people behaved in a particular way. When a few ships had radar, they behaved in unpredictable ways because they saw things that were hitherto invisible. And then eventually, when radar became in, then the few ships that didn't have radar behaved in unpredictable ways. So the management risk has these human elements that are difficult to predict without a detailed scenario analysis. And in retrospect, this is a story that we might have been able to anticipate, had we brought the science to bear at the beginning of the process. And I brought my own member of the general public, so there's, my wife is here, so there's three of you, so there won't be a tie if you vote on GOF, so.
Okay, thank you. Next question from this side.
Okay, my name is Steve Kreidinger, and I'm also a risk and policy analyst. But one thing to note about risk analysis is that many risk analysts actually see risk analysis as impossible to separate from decision analysis. And one thing which was not presented over the course of the last couple of days was a map of the space of potential policies which one might implement in order to mitigate these risks or make gain of function research more mitigated. And there was very much of a biosafety frame, I thought, in the discussion, and limited detail about biosecurity. There was very much of a national frame as opposed to an international frame. And the maybe or maybe not gain of function research, where you don't know before the experiment starts whether it is or not, was mentioned, but policy alternatives to this weren't addressed. So I'm interested in your comment. The few distinctions I made are material but don't map the policy space, and I would encourage the NSAB to do a very careful job of mapping the policy space in addition to mapping the risk space as it continues its deliberations. Thank you.
Thank you. Anyone on the panel want to respond to that? Okay, question on this side.
Well, I would just make the general point to follow up is that what's important in terms of information that we produce depends on the decision that we're making. Information that's critical for some decisions isn't others. So without a specification of the decision space, analytical resources are likely to be wasted.
A question for Bob Lamb. Thank you for showing the table from our paper and for your comment on it, which I basically agree with. I don't think that the alternatives of the ones that you listed there are designed to do the exact same, find the exact same scientific knowledge as those of the controversial gain-of-function research. My question is, you mentioned as one of the alternatives that you saw work on less pathogenic strains as a less risky alternative. Given that we are not yet at the point of direct policy application, as you said, do you see a major advantage to doing, or any advantage to doing the work, the ferret work, the transmission work to find mutations and phenotypes at this stage of the game in highly pathogenic strains, as opposed to trying to find generalizable properties of less pathogenic or even better hemagglutinins that we already know about, already have immunity to, for example?
I think it depends entirely on what you're trying to investigate. And that is if you're after pathogenicity with high-path viruses, and what makes them so virulent, and can they transmit? Could the virus transmit from one animal to another? You're stuck with working with the high-path virus in a ferret. I don't see any choice to that. If you're asking a more general question about the hemagglutinin, then perhaps you can use the low-path hemagglutinin. But if you want to understand pathogenicity and transmission of an H5N1, for example, then I don't think there's an alternative but to use the virus.
I'll leave it at that.
Okay, question on my left.
Hi, I'm Andy Kiliansky. I work for the Department of Defense. My question is for the panel at large. This has been the second sort of moratorium in the last 3 years regarding this sort of research. And it seems like there's been a lot of focus on HPAI for good reason, but also in this moratorium, SARS and MERS. So, you know, we're all gathered here. We're not doing the research, right, that we get paid to do back in our labs. So I guess my question would be, what do you think should be the path forward so that during the next outbreak of the next pathogen, we don't all have to stop working and come together and answer and ask some of these same questions that might have been brought up in the past?
Who cares to respond?
Just to take probably an inappropriate metaphor, I think this set of issues has sort of been kicking the can down the road as far as the type of more broader public engagement that needs to touch on what kind of governance systems we want for the life sciences on which we really do rely for very important developments. So I think that this issue and comparable ones will continue to emerge, and that's why I think we really do need to develop these enduring structures for diverse points of view to be aired and articulated from different areas of expertise and different sets of values.
Any other comments from the panel? Baruch?
So I'm a newcomer to this area, and the feeling that I get here is this is a sad and potentially tragic example of the failure of our political institutions to come up with a credible way of treating public health issues as matters of public health, which inevitably involve political, ethical values. But this seems like an area where we ought to be able to come together and come up with some reasonable rules, and if we can't, shame on us collectively.
Thank you. On my right?
Piers Millett, Biosecure Limited. I'd like to start by thanking all of the speakers for a tour de force of looking at how to look at risks and benefits. I'd be interested in your comments on whether you think such approaches will be used when this discussion happens elsewhere in the world. And to prompt that discussion, I'd like to, with your indulgence, read one sentence from the government of Pakistan's opening statement to an international meeting we heard about yesterday. And it reads, and I start the quote, "There is an urgent need to strictly regulate the industry and various laboratories in the public and private sectors in the wake of various reports concerning experiments that have been taking place with highly contagious, virulent flu strains like H5N1, motivated mainly by commercial interests." And that was backed up by similar sorts of statements on behalf of 130 countries around the world. So your comments on how the discussions we have today connect with broader international discussions.
Responses?
Well, just to piggyback on Baruch's point, I think in Pakistan in particular, there are political pressures which the government, I think, is well aware of the need to make sure that the public is confident that there's public safety is top of mind. And I think that that's part of what's going on here in the United States as well. One of the benefits of having a rigorous risk analysis process and accountability structure is that you can actually sort of point to that if and when there is a subsequent event and say, well, either it went wrong and here's who's accountable, or you know, we caught it in time and it could have been a lot worse due to the structure we put in place. And I think if you don't have that structure built in and you can't articulate it well to the general public, you've never tried, then you're really going to be on your back foot in dealing with these issues.
On my left?
Mike Imperiali, University of Michigan. Baruch, I was wondering if you could maybe expand a little bit on one of the parameters of the subject at hand in terms of how it fits into the risk-benefit analysis, and that is the issue of biosecurity threat, when a lot of that information either sits in a classified environment or just as impossible to kind of get your arms around. So how does one build those considerations into the analysis?
Yeah, thanks, Mike. I should add, Mike was on that, the committee, one of the committees whose reports I showed on ethical, legal, and social issues in dealing with technologies that could get out of control. It could be rapidly democratized was the weird euphemism that the community came up with. One of the reasons I think that design is better than, what was once called probative, rather than using the analysis to prove what it is that there are some places, like I think often in the security area, where really nobody knows what the actual probabilities are because the adversaries change. So even if we could read their minds today, we couldn't read their minds tomorrow, and that by trying to get it's like a nuclear, a risk analysis in another area where you didn't know the source term. Trying to produce an absolute estimate of risk is just a waste of time. So don't try to do that. Try to do what analysis is good for, which is to dissect problems and find the best way to do it. If one is deciding somebody then needs to decide how serious the external threat is, I think that one should be able to design an analysis that explains the sensitivity of the different choices to what that forcing function is, and then allows the people who have access to that information to decide whether you're above or below, where you are relative to that threshold. If they say, well, you really wouldn't want to do this if there's a large threat, making that somewhat quantitative, and the people who know the threat or have the best knowledge of the threat and are properly judicious about the quality of their information, then they can say, we can do it, or we ought not to do it. So I think that would be, to following up an earlier question, that would be a way of designing the analysis in order to feed the decision while still helping people to do it better.
Am I right?
Oh, Could I just add a little bit to what Baruch said? I'm going into an area where my colleague Gigi Quick-Rombal has written a great deal. I think it's important to remember what Carol Linden said yesterday. So options for managing the risk, whether it's intentionally initiated or accidentally, that there could be risk mitigation measures that cross both of those scenarios. So just to sort of build on that, Baruch.
Nicholas Evans, University of Pennsylvania. I've got a question for Gavin and a question for Monica. Gavin, one of the kind of key things that came out of your talk was that there's a role for cognitive science in understanding how we make risk assessments. And in particular, I wanted to pick you up on the matrices that you showed towards the end of your talk. To what degree do those matrices reflect the values that we bring into the risk assessment process? And to what extent do they reveal the values? I mean, so, we can come up with a set of values that we then apply to our risk assessment, but we can also have a set of background values that are shown up by the outcomes that we place on that matrix. And I wanted to gauge your opinion on that. I'll just follow up with my very quick question for Monica. A lot of your talk seemed to be less about the risk-benefit analysis process and more about the deliberative process as a whole. And I was wondering, after Gavin's finished, if you could speak a little bit to how you think engagement functions in the deliberative process as opposed to the risk-benefit analysis. Cheers.
Well, it's a wonderful question, and yes, I think the thrust of your question, they reveal initially, and if, of course, you can conduct the process without having such a tool, and your values will be reflected in your implicit values will be reflected in the process. But those implicit values might be at odds with something like a mission or a sort of a company brand or something like that. And to the extent that you try to build a matrix and you compare it with your mission statement, you compare it with your brand, you compare it with the sort of regulatory structure or thresholds that you think you'd like to adopt as part of a larger institution, and there's a mismatch, you then have to adjust the matrix to be in line. And that's the value of the process there.
Sort of building on what Gavin said, and if I understood your question, with regard to the benefits of deliberative process is the possibility for people to take in new information and reflect on their values. And that happens on the parts of governing officials, technical experts, and members of the so-called general public. So it's, when it's designed in such a way to allow for that two-way exchange of information, the questioning and dialogue, there's the possibility that values can shift, although those are can be fairly robust in certain ways, and I'll defer to Baruch on some of these matters. But the deliberative process, if designed well, allows for the evolution in points of view, taking in both facts and values as they are expressed by all parties.
On my left.
Mark Dennison. First, I want to thank you all for your comments on the cognitive sciences. From that perspective, I'm a member of the general public in terms of my background and understanding, so I very much appreciate that. And Dr. Huntley-Fenner, I had a question for you. That is, building on what Ralph showed in terms of sort of a recent survey that's underway right now and how quickly students responded and with what interest over a 24-hour period, over a weekend, essentially, to try to give us some insights and the risks that they all feel. It was sort of building on your comment about about cognitive function and reduction of cognitive function in PPE. In fact, many of us find the experience of working to BSL-3 kind of a Zen-like experience. It's actually really relaxing. It's very focused. It's very clear from these kinds of issues and concerns when we're working there. Mm-hmm. On the other hand, we're working with trainees. So another component I wanted to ask your issue on is what is the stresses, for example, that we're working with people who are also trying to learn. They're apprentices in a way, right? So the potential for putting sort of punitive or proscriptive approaches on them in a zero tolerance environment while they're working, right? A zero tolerance for error, the punitive response potentially to error, reporting at a national basis for a mistake that might occur in that. What do you think are the consequences of that, and are there ways that we can address that in these considerations that will relieve that kind of burden and allow for science to be performed in a safe manner, yet also ensure that people don't feel like they're at risk of losing their job or losing their boss's job or losing the job of every boss in the country or every laboratory?
It's a fair point and a really important one. I've been thinking quite a bit about this. I saw the survey on Twitter, by the way, speaking of the general public, yesterday, because I've been following the Twitter feed related to this meeting, and it's quite active. Let's just take the point about the student. I think that it's harder to be a student in a place that, or trainee in a place that doesn't value your opinion, or that where they say that there's certain values or things that are important, certain priorities, but then they don't act consistently with that. So if you and trainees are, I think, eager to adapt to the culture of a new lab setting. I mean, I know I was whether I was a postdoc or a graduate student, I was very interested in adopting the norms of the research environment into which I was placed. So I think it would be harder for a trainee to be in a situation where, okay, they say that safety is really important and they say the following rules are important, but I notice that so-and-so's postdoc never does XYZ and nobody calls them on it. Or that the other day when I thought I saw something that was a problem, I tried to raise it, and my lab director or my postdoc, whoever's supervising me, said, you know what, just do the work. I think those are things that are far more difficult than actually contemplating sitting in PPE for 4 hours. So I would really highlight the importance of culture, creating an environment where there's a consistent message, and that actions and students are empowered to act in ways that further the objectives or the missions of that lab as it articulated in the message.
I'm just going to take one more question from each mic. I apologize, and there's plenty of time in the afternoon or after the heavy hors d'oeuvres. Over on my right.
Johannes Rath, University of Vienna. My question goes to Dr. Huntley-Fenner. I really appreciated your presentation about the human factor and the importance of the human factor. The IAEA has addressed the human factor in the concept of culture and culture development, and they've invested and issued quite a few documents on safety and security culture in the nuclear area. Do you think that work on a biosafety and biosecurity culture would be beneficial in this context?
I'm sorry, so can you be more specific just about your...
What the IAEA did, they identified that the attitudes and beliefs of individuals working in this area is an important issue. And they called this the culture of the organization, of the individual. And they have developed guidance documents on how you can implement or how you can assess the development of such cultures in an organization.
I understand.
Okay, and if you go, for example, to the guidance documents from WHO or from the OECD on biosecurity, they talk about biosecurity, biosafety culture, but it's not a concept that is further developed. It's just mentioned there. But it needs to be filled with some content to make it then work.
I understand. I mean, here's what I'll say just very, very briefly. I mean, I think that it's important not to think about sort of culture as a static thing. And we can be very specific, think about safety culture. There are environments that were once the sort of paragons of safety culture and compliance and safety-mindedness that today are no longer. So unless we're vigilant about it and mindful, there's a descent into mediocrity. So I think part of what I'd like to stress is that vigilance is important, and you have to constantly work on it.
Last question on my left.
Hi, Adolfo Garcia Sastre. Thanks a lot for all your presentations. One thing that I found missing in the meeting in general and also in this presentation is a discussion of the already existing regulations, how they deal with the problems that we are talking about. There is select agent regulations that try to deal at least with human factors, and there is also DURC frameworks, where most of the experiments that we are discussing fell into DURC, where before you start one experiment that has dual-use research of concern, one needs to send a proposal with a risk-benefit consideration, as well as a risk mitigation plan for being approved by a federal committee that looks to these proposals and then either approve the research or does not approve the research, or ask for more information, or ask for an oversight of this particular type of research. And I wonder if someone can comment about whether it's believed now that these specific regulations are not anymore appropriate, or how they deal actually with the things that we are talking about.
So I'll just comment on that. Certainly in terms of building certain SARS variants or bat SARS-like viruses, we submit protocols to the IBC. Oftentimes, if there are concerns, we come and present to the IBC and ask questions. Actually, we answer questions. For certain protocols, we do have to develop dual-use research of concern, talk about risk mitigation, how we will inform the public, how the university will communicate that. And in those discussions, depending on the experiment, NIH may be concerned and consulted in the process. So as you quite appropriately stated, there is a extensive framework of regulation that already exists that, although it is currently designed to focus on 15 pathogens or toxins of concern, at the University of North Carolina, any type of gain-of-function experiment, at least that is done in our lab, receives much higher scrutiny.
Anybody else on the panel wish to respond? Okay, well, let me thank all the speakers, and it was a very good morning session.